Another kind of distribution that you would be required to calculate probabilities for is the discrete distribution called as Poisson. This was put together many years ago by a French mathematician and scientist, and it bears his name today. The properties of Poisson distribution are that the probability of occurrences is the same for intervals of time, because it usually is time or length of the same length, and the events that you're going to be looking at are totally independent of each other. Poisson distributions generally deal with occurrences over time or distance. Another thing to remember is Poisson distributions have no fixed upper limit. A caution, shown as red on your sheet, is that you need to make sure to express the mean in the same unit of measure as the question is posed. That's extremely important to remember when you're trying to solve Poisson distribution questions. With that in mind, take a look at the first question. What is the probability that less than 9 calls will be received in the next hour? Just like you had to do with binomial experiments, you need to understand what you're being asked. In this case, what is the definition of less than 9? Well, the answer is it's the cumulative value of 0 to 8. So what you need to do is you need to enter equal, type in Poisson and select it from the drop-down menu, and it will ask you what's the number you're looking at. It would be 8, and then look at the rest of the question. Less than 9 calls received in the next hour. The next entry that you're going to make is what is the mean? Well, if the mean is 6 for every 30 minutes, you need to convert 30 minutes into an hour so that the mean would be 12 if you were looking at an hour. Lastly, do you want a cumulative number or an exact number? And because you want the cumulative value of 0 to 8, you're going to enter true in the last or cumulative portion of the function. Selecting enter, you will get about 15.5% is the answer. When you do that, of course, the actual type formula disappears. So again, I have listed it alongside the actual answer that you've got. And you could see that it was Poisson, 8, a change mean from 6 to 12, and true so that a cumulative number was produced. For the next question, what's the probability that more than 6 calls are received in the next half hour? More than 6, that means from 7 until infinity. So just as you had to do before, you have to recognize that all of the results of a Poisson equal 100%. So we're going to say equals 1 minus, and then we're going to start typing Poisson. And again, it's going to ask us what numbers we're interested in. Well, more than 6, we're going to calculate what 0 to 6 is and subtract our answer from 100%, because what's left will be the probability for more than 6. So we're going to enter 6, and here the mean and the question are in the same unit. They're both a half an hour, so we're going to be able to use the mean as it's listed, and then we're going to say true. When we hit enter, we're going to get a little over 39%. Again, we're going to show the entry alongside of that. so that you'll be able to look at it in relationship to the answer that you got. 1 minus Poisson, 6 with a mean of 6, and true. The last question that's being posed is for exactly 5 calls, and the time period is the same. So that's going to be a Poisson entry again. And remember, anytime you see exact, that tells you you're not looking at a cumulative number. So we're going to enter 5. It's a half an hour period, so we're going to enter 6 as the mean. And instead of saying true, we're going to say false, because that will return what we're looking for, which is exactly 5 calls. Again, when we show you how it would be entered, you'll be able to see that it would be entered as Poisson. 5 is the number we're concerned about with a mean of 6, and false, so we're returning just the information on exactly 5 calls being received. With these 3 different types of questions, we've now covered everything that you could be asked about in terms of a Poisson distribution.